Happy New Year to everyone. Happy 2025. I hope you are all having a good start of the year. And I, for one, look forward to this presentation. Electrification on all buildings is obviously a really, really good thing. Um, and yeah, I mean, I'm looking forward to hear from Sean. So with that, I'll pass it along to Sarah so she can introduce Sean and we can get going.
Hi, everybody. Good morning, maybe good afternoon to some of you, maybe good evening, depending on where you are. I'm excited to introduce Sean today because this is a topic I think is really cool, and I'm excited to learn a little bit more about it myself. But I won't hold you guys up too much. Let's introduce Sean. So, Sean Armstrong is the managing principal of Redwood Energy, which is the nation's oldest all electric residential design consultancy. That's pretty cool. Between 2007 and 2020, Sean led the design of half of the ZNE residences built in California and a fourth of the ZNE residences in all of North America. Following his mother in law's death in the 2017 Tubbs fire in Santa Rosa, California, Sean hired leading environmental lawyers in 2018 to devise legal strategies to ban gas in buildings that were adopted in Berkeley and 80 other governments nationwide. That's kind of awesome. He's co authored 6 guides to building electrification, so he knows a thing or two. And he's received the grand prize in the United Nations World Habitat Awards, an introduction to California's Clean Energy Hall of Fame. So it is totally my honor and my pleasure to introduce you guys to Sean Armstrong. Hey, Sean.
Woo! Thank you so much.
Woo!
Appreciate it, Sarah. All right. We're going to jump right in. 101. So here you see La Jamais Content, means the never satisfied, the fastest car in 1900, 0 to 60 in like, I don't know, 20 seconds or something. The fastest car. I love this like really angry looking French dude on this little bullet car. So we're going to accelerate, just like he did. As mentioned, I have a long, deep background. I started in 1995 as an undergraduate learning how to do building electrification in this demonstration house up on campus. And I was a high school science teacher, but then as mentioned, I went into development and went hard on the all-electric, zero-net energy housing. So, history. I'm going to present this class as a little bit of stories. And as along the way, you're welcome to ask questions, and I'm hopefully going to illustrate technical concepts for you, but I like stories more than a lot of things. And then I also have some pretty nerdy stuff that's like the last third. So, bearing with me. Heat pumps, this technology that absorbs about 3 times up to 5 times as much energy as it actually takes to operate the machine. It absorbs it from the environment. They were invented by a drunkard. Not exactly. He was actually a typesetter, but what he felt was the ether boiling off his hands when he was cleaning keys, like in 1854 or so, and it was just freezing his hands. And he's like, man, if I could just, capture this magic in a bottle, so to speak, I could really make some money. And he did. He invented a strategy for recycling this refrigerant that was boiling off his hands, ether, so that he could chill one thing while dumping the heat elsewhere. Pump the heat out of something is how they used to think of it. Take the heat from one place. And that was immediately adopted by the beer company. So you see here a heat pump by Anheuser-Busch in 1882. All the first heat pumps were just making ice. See on the right-hand side, ice delivery during World War I. Ice was delivered all the way up into the 1950s when finally heat pumps got small enough that they can make the refrigerator and the freezer really work well. They started like in the 30s, the 20s and the 30s, the official machines. 1935, it's a big year. At that point, 90% of people who lived in cities had electricity. 90% of people who lived in the country did not have electricity in the United States. And so during the Great Depression, in order to bring heat and cold and, the radio and pumps that worked, all the good stuff, lights. This is a kid who is looking at his hybrid tractor. It's his first tractor that has a battery. And you see the battery charger on the wall. So you could start the tractor without having to mechanically crank it. You could use electricity to spark it. So the REA, the Rural Electrification Administration, from 1935 to 1959, electrified 60% of the land mass of the United States. And I grew up in a rural co-op, what they're called. Essentially, government would loan money to community organizations. And if they did all the work of putting up the poles, then they got to keep the money. So a lot of our country, the majority of our country, is physically installed by people just putting their shoulders to the wheel. Westinghouse and General Electric were the two big names. Westinghouse here, this is their all-electric demonstration house in 1936. Thousands of people came to it. All the architects in their country, they wanted to go to this. It was written up. It's a big deal. Look, there's a radio. There's a telephone. I mean, for Christ's sake, this is modern stuff here. You know, she's got an iron out, an electric iron, not one you had to heat on a wood stove and then press it against fabric. These ladies over here on the side, you can see there's a little like heating vent below them. They've got a radio. This is all signs of luxury. And then there's a wall panel that electrically heats different walls and floors. That had like this really sophisticated radiant heating system that came from all the different sides of the building. I just love like they're in furs and things like that. This here on the lower right hand side, this is one of the advents of electric cooking. It's a real trend. People, of course, that cooking it's the hearth of the home. It's emotionally the most important part of the house. I really lean into explaining how cooking works better electrically. They were doing it back then in the 30s. Like, look, this is an electrically heated warming cabinet. You come out and we have different cabinets that have already been heated to the right temperature, so you can have a super fancy meal and have everything at the right temperature. That's there's always been a focus on electrification of cooking as like the way to people's hearts. So that's the drawing, very Art Deco. Is that what you call this? Art Nouveau? Where are we at? Someone help me out. There's a real architect. What do you think is the design aesthetics? 1936.
Deco.
That's Deco, yeah.
Okay.
Art Deco.
That's the one. So you can see the house is up here in Mansfield, Ohio. It still exists. It's behind, you know, some bushes and such. 1950s, heat pumps come into homes. Oh, what luxury to actually have air conditioning blasting at you. So what air conditioning is it's sucking the heat out of your house, blowing cold air at you, but essentially air is going into the machine and it's chilling that, and you're getting the cold air from it. The heat that's been chilled is now being blown outside. And if you've ever felt an air conditioner when you walked by it outside in the summer and you felt the heat blasting you outside, it's just moving of the heat. The moving of the heat, as I mentioned before, is when something boils, it absorbs heat. And so they take liquids, all different kinds of liquids that boil at different temperatures, colder and colder, like boils at negative 30 degrees Fahrenheit. This is all the refrigerants we use now, negative 30, negative 50. CO2 is negative 110. And because it can boil at that temperature and suck heat in through the boiling process, maybe 10 times as much heat as any other part of its process. Like it's right at the boiling point that it sucks in tons. So here you have it, air conditioning in people's homes. So the Westinghouse and General Electric hired this retired washed up actor named Ronald Reagan in 1953. His last film was literally with the chimpanzee. And they hired him and said, hey, could you be the face and the voice and the organizer of this TV show? We want to make a hit. And he's like, yeah, I'll do that. I already found Marilyn Monroe. Like, I am a man here. I know my stuff. I'm a Hollywood dude. And so they built him a mansion on the lower right-hand corner. It's an all-electric mansion, electrically heated swimming pool, electrically heated outside heaters, like little heating elements you'd stand underneath and get all warm. I'm tall, I'm 6'3". When I go to parties and they have the propane heaters, it literally makes me sick because I'm getting the carbon monoxide poisoning right in my face and it's like burns my scalp. So electric, at the minimum, doesn't poison you. So Ronald Reagan, he would do this show. He'd have James Dean on, like literally every Hollywood star, without exception. They went to this #1 show on Sunday nights, and they did theater. And then in the advertisements in the middle would advertise electric servants, which is what they called them, like your coffee pot. It was an electric servant. A little weird, but you know, it's the 50s, back when they had drawings that still showed like servants' quarters and like where the maid lives and things. Those of you architects, if you look at old plans, you're like, who makes a maid's quarters? But that was a thing then. So great television show. The magazines, the articles, like there's just so much memorabilia from this era in which General Electric and Westinghouse, then joined by almost 2,200 national utilities, were pushing behind the scenes to get a change in the code. They wanted 100 amps at 240 volts delivered to every house. To do it, they would mock people. They'd say, like, are you a galley slave? Or are you a lady in waiting? Or are you a dinner duchess? Do you have an electric range? Do you have a wall oven? Do you have they give you these advertisements for you to go down and rate yourself. And they just go hard on your emotions. Like, look, families love to get together in a wonderful, cozy, all-electric home. But what they're really doing is making it so that the code went from requiring 60 amps, which is not quite enough to get to an all-electric home, to 100 amps. And they won. Code changed. They changed the laws. So the National Electrical Code, which is organized by the National Fire Protection Agency, the NFPA is there to prevent fires. This is all about safety. So a nice, safe all-electric home had 100 amps. So having won that, they actually they let Ronald Reagan go. And they hired on Julia Child, who was a former CIA agent, and she'd invented all the way up until like 1990s the only shark bait. What was it? Shark deterrent for land water mines, like underneath the water. There's little mines that blow up boats, and they would coat these with shark deterrent so the sharks wouldn't set them off. Julia Child invented that shark nastiness of like rotten this and rotten that. She always cooked on electric because she was hired by the Long Island utility. So she's out there in New York. And here you can see she has 4 electric resistance burners. She'd set them at different temperatures and show people how to make really fancy food. And she'd just be juggling pots and pans around. We all like, oh, electric resistance kind of sucks. But she's like, no, this is excellent, accurate cooking. It might be a little slow to heat up or cool down. So if you've ever seen Julia Child cook, you've only seen her cook on electric. Ronald Reagan, an important character, a through line, while he was doing that 10-year stint of organizing the General Electric Theater, the #1 show on Sunday nights, so he gets laid off in '63. It's kind of because he'd done a little shady business when he was head of a union and he got divorced and he did some work he wasn't supposed to do, blah, 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 gossip, gossip. Mostly what he's doing is he's opening up nuclear power plants, the clean energy of the future. He was a clean energy advocate. Something people don't realize is that he was trying to push for reducing smog throughout the nation. He's like in California, and LA had the first smog in our country. It's got a basin of mountains around it. The smoke does not blow away, and you just end up, stewing in your own filth. So in the lower left-hand hand side, you can see one of the nuclear power plants that opened, and he personally visited every nuclear power plant for about a decade as it opened via train. He's very scared of airplanes. Then he ran for governor in 1967, gets into office facing, like I mentioned, the worst smog in the country. And so in 1967, one of the first things he does is he passes the California Fuel Efficiency Standards. And he gets an exemption from Richard Nixon, a fellow Californian, in 1970 when the United States passes our first and only Clean Air Act. This exemption is the same exemption that California uses today to require electric vehicles. It's the same exemption that you're going to see politics around for the next 4 years as Trump once again tries to revoke it, as he tried to do in this previous administration. FYI, the past is the present. This is the law. This is the exemption. This is how it went down. Reagan and Nixon worked together so that California could set higher standards because our law had preceded it. I say our, even though I'm from Wisconsin. I live here. So that is why California leads in our nation in electrification ordinances and laws. We have special dispensation to do so. Ronald Reagan is still the governor. In 1974, when OPEC banned sale of gas in the United States, we've been doing a lot of monkey business in other countries' governance, overthrowing their duly elected leaders, and that's a real thing in the 60s and 70s, nasty stuff. So with electricity prices quadrupling overnight because electricity is being produced mostly with fossil fuels and not with nuclear power yet, Ronald Reagan signs a law into California called the Warren Alquist State Resources Conservation Development Act, which he thought was going to promote nuclear power. It's like, we're going to set up a test, it'll be cost effective. And then in 1975, a new federal law passes, and once again, Reagan goes to Nixon and says, can I get an exemption for that? And that's why California can set building codes that are higher. I've mentioned previously, this is vehicles, right? Electric vehicles. This is electric buildings. Same idea. A legal exemption is built in so that our more aggressive laws can be enforced. Reagan's out, Carter's in, rest in peace. Carter still dealing with the oil embargo, and then he's got a second one because there's a whole bunch of hostages that are taken by Iran. Reagan, behind the scenes, prevents those hostages from being released so that Carter loses the election, and then has them released on his first day of being president. That's nice stuff, huh? Those hostages had a little longer, they got to wait in jail. So Carter, he leans heavy on conservation. Conservation is the only way we can buy a barrel of oil for a few dollars. He puts these solar thermal panels up on the White House. Reagan took them down in 1987. It was not his first act, as sometimes is reported. He wasn't that much of a hater. And in 1979, the nuclear ambitions of Reagan really come crashing down, and they've never recovered in the United States. You see that school bus, right? That is the 3 Mile Island nuclear accident. 3 days of nuclear radiation steam being released without informing the neighborhood next to a school, right? In the middle of Middletown, Pennsylvania. You can't be more middle of America than Middletown, Pennsylvania. This rocked everything. The whole 1980s, 90s, everything changes. Nuclear power is considered a danger, even though it's clean, even though it provides significant amount of electricity for our country. It is now also the most expensive electricity that you can develop in our nation. There's no more expensive electricity than nuclear power. Georgia just proved that again with their Vogtle plant. So the 1980s are kind of a weird time. Ronald Reagan is now president, and he chooses a vice president that's an oil baron. Bush the first was an oil millionaire, as well as the head of the CIA, which I mentioned had a lot of involvement in other countries' oil business. So nuclear is not on in the ascendancy, oil is, and in the background, you have the weed growers of Northern California who are buying all this NASA expensive grade solar panels. This is where I am right now. I'm in the center of cannabis cultivation in our whole country, Humboldt County. And so I got trained by all these really experienced solar installers. Very unique experience to have, like in college and such, because these panels were like $5 to $10 a watt. They're like 15 cents a watt now. We've had more than an order of magnitude drop in cost. It's like 1/100th of the cost it was, not even 1/10. 2 orders of magnitude change in my lifetime from being a college student to now, and the price of solar. Driven and supported for about 30 years just by the cannabis industry, trying to do off-grid houses that the cops can't find. And so they set up their own electrical system. So that's a lot of my background, is like pedal power, biodiesel, wind turbines, but solar panels were the one. So here in California in 2006, the next big change happens. Schwarzenegger, a Republican governor, signs a law organized by Democratic congresspeople. You see here Governor Newsom back when he was mayor, and he just legalized gay marriage. First elected official in the nation to do that. And here you see Fran Pavley on the left-hand side saying, Schwarzenegger, don't screw it up, man. Sign the thing. She's the author of it. She's down from where there's a fire today in Los Angeles, Malibu, Palisades. That's her district. And that district is still the nation's leading elected officials come from that area. It is so vulnerable to climate change and so wealthy at the same time. A lot of power and money all in one place. So in 2006, Schwarzenegger and the crew, they set the goal that by 2020 in California, we're going to have an all-electric building code, no gas allowed. The gas companies in California do not believe it, and they fight it to the death. We still do not have an all-electric building code, even though it's set in law. And here we have another bipartisan law passed. You see Nancy Pelosi there in the left-hand corner in red. And then there's Bush. And so they essentially passed the California law as a federal law as well. And this is the same thing we've seen 2 other times in this presentation. This is how our country works. So these laws that are passed set up financial incentives for solar power and set up policies to require all electric that are so enforced. As Sarah mentioned in the beginning, I worked hard to get laws passed in California that ban gas. We'll get to that story in a second. But in 2009, something really big changes. I'm going to start introducing you to some of the technology concepts that have given you a little bit of like the softer, gauzier, this is how we got here part of the story. So if you remember in the 1990s, computers were big and they got small quickly. And there was like orders of magnitude reduction in the amount of space that a computer took. In 2001, Oak Ridge National Laboratory starts experimenting over in Tennessee and adding computers to heat pumps. And in 2009, Japan actually has been manufacturing these. Japan is the center of heat pump design in our world. Japan is where you see the most of them design because they have very expensive electricity only from coal and some nuclear power. You remember how that went down in the 2011 Fukushima earthquake? Like, they have nuclear power and they have coal. That's it. Two of the most expensive sources of energy of all. And it's inflexible. You can't turn nuclear or coal up at night when people come home. So Japan has always invested more than anyone else in energy efficiency of heat pumps and electrification. That's why you get heat pumps like Mitsubishi being the first ones to put computers in. What computers do is that, you know, like when you grew up on a single speed bicycle and you put the back pedal down to like hit the brake and you'd like pedal forward and you had just one speed. That's what heat pumps are. They're literally a one-speed device. Your refrigerator works at one speed. The fan inside of it, the pump inside of it, one speed. You add a computer, it's like making a 100-speed bicycle, something that goes on the Tour de France. You can set the fan and you can set the motor pump inside to any speeds you want, which means that when it gets cold outside and you need to collect more heat from the environment to keep your house warm, you can accelerate the fan. The computer does it. It says, oh, it's 20 degrees outside. I'm going to set the fan speed to this, much faster than it is when it's 50 degrees outside, because I need to collect more air to squeeze more heat out of it. And same thing with the internal compressor heat pump device. It's a little capsule with a little like weird oblong pump thing inside of it. Anyway, not a whole lot of point in showing what that looks like. It's a little capsule. But this is a big moment. I bought a 2009 Mitsubishi heat pump when I was building my mom's super insulated tiny house next to my larger house. My house is 1,100 square feet, larger. I call it the big house. And things change. In 2010, we start seeing a nationwide trend of market share change. Every one of these counties that you're looking at here between 2010 and 2014 shifted from, say, using natural gas in light blue or propane in darker blue or wood in red. They shifted where all of a sudden they were starting to install more heat pumps. This illustration is from the Propane Education Research Council, and they published it in 2016 because they're freaking out. They're like, why are we losing market share? And the answer is they put computers on heat pumps, and now they work in Wisconsin. They work in upstate New York. They can finally work at -10 degrees Fahrenheit, -20 degrees Fahrenheit. It's all about the addition of the computer to be able to accelerate or deaccelerate the fan and the pump inside. So market share gain starts in 2010, and it is leading to the end of the propane industry, according to them. They're very sad about it. I just like this picture, and I spent so much time making it, so just look at it for a second. Pick out your favorite star. I am the kind of person who goes on YouTube and watches people's home tours of stars, just so I can find out if they have an electric stove or if they have solar on the roof or such. And all these people were early solar adopters. Prince, what a man. That guy, he put huge amounts of money into an accelerator in Oakland that's like got 40 different renewable energy companies within it. And he just dumped a bunch of money in it and walked away because, you know, he's Prince. Let's see. I mean, all of them, all the Avengers pretty much have done it. Even like Lou Ferrigno, the Hulk when I was a kid, when it was still in black and white, solar on his roof. But pick your favorite star. These were all people who put their money where their mouth was, so to speak. Oh, by the way, Jamie Foxx, he has a huge solar array. That guy like covered the side of a hill with a massive solar array to do his all electric mansion. Really impressive. Biggest one I ever saw. Okay, so this is Santa Rosa. This is our first climate change fire that everyone's like, what is going on? Burnt down many hundreds of homes. Killed dozens of people. One of them was my mother-in-law. She died of smoke inhalation. She didn't die in flames, thank God. But it was really bad. And it made me cry. I used to cry every time I give this presentation. I'm kind of past crying. It's been a bunch of years. But it was absolutely one of the worst things ever. And I was so goddamn pissed. because I had been building all electric, 100% solar powered housing since 2011. And I could see that the building code officials, all of them were like, we don't believe you. We don't think it's possible. We literally don't know what a heat pump is. Like the head of code development, the head mechanical engineer, didn't know what the rest of the country is using. They just didn't know, and they wouldn't learn. And people are dying over this stuff, and we weren't getting the code that the laws called for. Very upsetting. It was just too upsetting, really. And so I hired lawyers and said, help me figure out how to ban gas. Like I've already been a city activist. I've done ordinances and things. I know that cities can do this. So this is me presenting for about 2 hours straight at one of the electrification expositions that the Bay Area started to hold. And you can see that the city council here passed a gas ban. They used the legal resources that I'd collected with Climate Imperative, Bruce Nils, and Panama Bartholomew of the Building Decarbonization Coalition, total heroes out there. You can see Pierre of the Natural Resource Defense Council here in the back. He was a doubter. You know, he was like, I don't know about this all electric thing. Now he actually co-owns a heat pump manufacturing company. Times have changed. Yeah. So you can see all these activists with burning passion, so to speak. And I'm up there just being outraged. And they're like, okay, we'll absorb your outrage and we'll do something. So those gas bans in California, which grew, there was one every 2 weeks. City councils passed one every 2 weeks for about a year and a half. It was just nonstop success. And you can see Alexia Ocasio-Cortez, I think I'm messing up her first name because I'm just on the moment here. So these are some of our senators and representatives who are real climate leaders. Some of them are still in office. And they started calling for a Green New Deal that had electrification built into it. And we didn't get a quote unquote Green New Deal. We got an Energy Independence and Security Act, which had a lot of electrification language in it. And you know, this is how the sausage is made. You know, get it through Tim Manchin over here. And that's been a big deal. You know, there's a bunch of money. There's been a whole bunch of movement in the country. We've acknowledged that all electric is our path forward. It's both Republican and Democrat as a concept. I mentioned before, let's see here. I want to show you this. I'm going to show you that previous slide in a moment, but this is today how all electric construction is found. What do you see about this? Just think about the blue and the reds and where's the purple in the electoral thing. Notice here that the most all-electric state is Florida, and the second most is Hawaii. These are two, that's a Republican state and that's a Democrat-controlled state. The South has led in all-electric construction the whole time. California is 8% all-electric construction. Texas is 37%. You know, this is not a Republican-Democrat thing. This trend here is around making money, because developers build 95% of all the residences in the United States, not rich people building it for themselves. So what you're seeing here is what developers have been doing since the 60s, which is that if it was warm enough to have a single speed heat pump, that's what they installed. They built an all-electric home because installing gas is always more expensive than building an all-electric home. And then in the northern states where we didn't have computer-supported heat pumps until 15 years ago, you see low rates like 7%, 13%, although even South Dakota is at 20% because it's still cheap to build, just is. California, because of our separate laws I've mentioned, and the ignorance of some of the leadership and the intense fossil fuel basis of our utilities, we have been one of the worst laggards in the nation, even though our climate would support it. So really been swimming upstream here. But this is what I want to show you, is that this is the policy evolution. The Bay Area Air Quality Management District, BACMUD, and the California Air Resources Board, CARB. These are two leading agencies. BACMUD has already adopted bans on gas water heaters and gas furnaces starting in 2026 and 2028, respectively. CARB is adopting similar policies, and CARB has a mandate to reduce through policy now 90% of all the climate change pollution that's being produced each year by 2035. And so now they're passing laws that have already, like you can't have a tortilla, you can't have a Frito-Lay in Los Angeles anymore that was made with burnt gas. keep in mind, like Frito-Lays, they don't cross the Rocky Mountains because the bag will explode because of pressure change. So they're all being made in the Los Angeles district. And the South Coast Air Quality Management District, which has 50% of all Californians live in this little strip around Los Angeles, which in turn, get this, that's 1 in 16 of all Americans live in this area around Los Angeles. And now all of those chip manufacturers and such, the food makers, they've had to already convert their gas-burning equipment to electric to try to address smog. So we're on a very clear regulatory path in California to eliminating 90% by 2035, which is not long from now. Pretty real. It's already changed a whole bunch of things. So I showed you this national trend. Now I'm going to dig a little bit more into the technology. But before I do that, I should go to the chat and be like, have I been missing questions? Because I know I talk fast. And who's Mark Ruffalo? Oh, where's Mark Ruffalo? He's there. You didn't see Mark? He is in he's one of the Hulks. Right there. Pretty boy with the glasses. There you go. Mark Ruffalo. There's actually one Hulk who didn't put solar on his homes. It was not Ed Norton, obviously. But I'm trying to remember his like Australian guy that got one movie out of the deal. He didn't put solar on.
Eric Bana.
That guy. Spit on his name. Not enough solar. I mean, he's a green giant. Where's his solar? Let's see. For gas stoves in the kitchen, at least. Nerd alert. Absolutely. Guilty as charged, it says. The fires continue. Harvest Thermal, that's right. You saw Mary James, that's the product that Jane and Pierre are putting out. Alexandria, thank you. Alexandria Ocasio-Cortez. Yep, Joe Manchin's a coal baron. That's why it happened.
I think we're just all so enthralled in your presentation. It's so many cool facts and context to learn from.
There you go. I was trying to make this fun as best I can. I give a presentation once or twice a week, so I've practiced. So this is what architects do, which is that they dissolve the entire city around and make it just like put a building on top of. This is actually in the context of the city of Petaluma. There's a train station next to it. There's warehouses, all the rest of it. But this is a cool drawing of a project that I've got a whole bunch of grant money on, like $15 million, to take an $80 million project, make it $95 million, to take it off grid. So this is a challenge, like, can we have a 100% solar powered residence, even knowing that in the wintertime, you get 1/5 as much energy on the winter solstice as you do on the summer solstice? Can you do it? Can you make a building that can save enough energy in the wintertime and have enough solar energy? This is what it might look like. This is a version that has more solar and less battery. Since this drawing is made, we've eliminated the carports of solar that span the roadway, which we elevated to 14 feet so the fire department could get underneath it to roll around. We don't need to do it. How we pulled it off was we went from having a 2 megawatt hour battery to having a 4 megawatt hour battery. So instead of solar muscling our way through the worst of the winter weather, we're saving some of the energy, a little bit more of the energy. I learned that, when PG&E was having to deal with wildfires that they were causing from not maintaining and instead shipping all the profits to New York City to all the shareholders, it was just illegal, which is why they went bankrupt for their criminal behavior, and why 88 convictions of manslaughter in Paradise, and they burned down an entire city and killed a whole bunch of people because they decided to not maintain power lines around Paradise. Fully documented, 100% wrong. To not even revisit a pole that's been up there for 100 years. So yeah, tons of profit leaves California, and it puts us all in jeopardy around here. I'm not a fan of the investor-owned utility model. Investor-owned utilities like PG&E charge 3 times as much for electricity as the municipal utilities right next to them, like in Sacramento, Los Angeles, San Francisco, San Jose. Anyway, that's my little profit motives, killing people kind of feeling. But anyway, this is a almost passive house design apartment complex. I'm going to go into some details. First off, inspired, you guys probably know Tim McDonald. I mean, I've got such a man crush on that guy. God, Tim McDonald. He does the coolest projects, and he has got such great information. Okay, so Onion Flats is his company. He's over in Philly. And he was kind enough to share pricing, $169 a square foot for his passive house canopy solar with these colored panels on the walls to tell people they're randomly assigned, so you can't figure out which apartment is yours, or you can't figure out whose apartment is whose, supposedly. But the green, blue, red, etc. is supposed to tell you for each apartment how you're doing for energy consumption. I've done a lot of work on that, by the way. It's not a very effective. I apologize. I've even made meters for it, done huge deployments of it. People don't change their behavior very much at all around energy consumption, no matter how much you teach them. So it's much better to focus on a passive house envelope. High efficiency heat pumps. That's where to do it. Spend your money there. Here you see on the right-hand side, Tim has completely wrapped this 4-story tall building in solar panels. It's all electric, 100% solar offset. I don't know if you call that pretty, but it is technically, it does the job. It's our biggest zero net energy project in the country. $157 a square foot. Prices, of course, would have gone up since COVID because these are in the teens. These projects are being developed. But what his point was is that he was doing these zero net energy passive house developments for the same price as people who are doing conventional buildings. He's making different choices, but they were coming out on the same budget as much less efficient, crummy buildings. Okay, so I'm going to show you a couple of the few cool things about this project that we're starting construction on in June. This off-grid solar-powered apartment complex, 131 low-income families. So one of the big moves forward is using thermocork. Thermocork is a 2 to 3 inch siding material. It's wood siding. And cork is the fire retardant bark of oak trees over in Portugal. They have huge wildfires there. And the oak trees there, like in Wisconsin where I'm from, there's a bur oak that has really thick bark. Same thing, oak trees, if they live in fire-prone areas, can develop very thick bark, which is what cork is bark. And if you've ever had rice cakes, I had terrible allergies as a kid, and I wasn't allowed to eat bread, so I have way too much experience eating rice cakes. Nothing like a nerdy little kid in rural Wisconsin coming to school with rice cakes. So what you do is you take cork and you expand it with heat and pressure, just like you do with rice. You basically like pop it, like popcorn. And in the process, the little cork granules glue together their own lignin, the goo that's in the bark, the sap, so to speak. It glues all together. And so you can get these sheets that are R4 per inch that are fire resistant and mold resistant and all the good stuff. And they're siding. I've had for now 10 years outside of a tiny bathroom. I do a lot of little experimental tiny buildings for my green building such. Unpainted, just like this you're seeing here. 10 years later, working perfectly, looks great. I might suggest that you paint it because the sunshine does take a toll on everything, you know, all that radiation. So I'd say paint it. Thermocork, they advise that you put a lime plaster on. Concrete plaster will burn it, but lime plaster is good for it. Pardon me. So embodied carbon, which is the carbon that we're producing right now when we build the building. Like I'm an expert at operational carbon, all electric, solar powered, put some batteries on it if you need it, great. But this is kind of a big step forward for us to study how can we get a 30% reduction in the carbon that we're making today just building the project. So we got a baseline and we got rid of 14% by putting cork siding up instead of cementitious siding like hardy plank, you know, cementitious fiberboard. It's a big move because that cementitious part of it, the cement, that has a huge amount of carbon. All the cement that we have in our country is made by burning gas. And you dehydrate and chemically change limestone, and you make it so you can just add water, you know, make a new rock out of it. But it's all gas that was burnt to dehydrate it. So the second most effective measure was putting low carbon concrete underneath the building. So we got 14% with the siding and an extra, would it be 8% with the cement concrete. And then we get another 3% by low carbon gypboard, you know, drywall. Another 2% by using cellulose batting instead of fiberglass batting. Another 2% by going to linoleum flooring instead of vinyl tiles or whatever, you know, some fossil fuel derivative. And the last one is the mass timber carport that I was showing over for the solar arrays. to get you some sense of where's the best bang for the buck, it's the siding. It is absolutely the siding. That is the one big one that people are not focusing on, is cementitious siding. It's a huge volume of it, and you can put thermocork up and change the whole deal. But before I jump on that, are there any questions about that? I'll just look in the chat because, like I said, I'm trying to be a little bit less rapid. Yeah, Eric, I have mentioned the LA fires. Absolutely climate issue. The legislatures in California that are the most hardcore on trying to get all electric are from the place where it's burning down right now. That's their town. Oh, thanks, Michelle. Dale, you're opposed to off-grid. Me too. We were winning a grant, and I'm going to show you, we're actually doing an on-grid. It is, we're turning that solar array and the huge battery we're putting into a grid resource, which is way more complicated than you might think. Yeah, we all love Tim. Hashtag man crush. Cold climate example, Google Bridge Review at Story Mill neighborhood in Bozeman, Montana. Zerna Energy, yep, good stuff. Love Thermocork, thank you. Surprised the Northeast is more orange than green. Is this the one you're looking at? Is it more expensive to dig in the rocky terrain? No, what happened was that since heat pumps didn't work in the north unless there were ground source heat pumps, which are very expensive and limited, air source heat pumps is what you're seeing all throughout the South, or electric resistance heating. And because they had air source heat pumps that worked all winter long in warm winter weather, that made sense. And in the north, where air source heat pumps, which were affordable, they just didn't use them because, yeah, the technology didn't work until recently. Okay. This question here that Katarina Brooks, you said maybe not enough sunny days to make it worth installing solar panels. No, where I am in Humboldt County, this is the cloudiest part of our nation. We have the least solar access anywhere in our country, even worse than Seattle. This is the worst. And this is the nation's leader in installing solar up until solar got really cheap. There's still enough solar here to do the first zero net energy, 100% solar offset apartment complex in the nation is downtown Arcata, which, as I said, the worst solar resource in our country. It was the first project ever built. That was an apartment complex. The first subdivision, like 26 houses, similarly terrible climate in Fort Bragg here on the coast. So it's not about the sunshine. Okay, there's a whole bunch of stuff there. I'm just going to present for a second. But Noah says, what do you think is the low-hanging fruit building type or HVAC system for electrifying existing multifamily buildings, especially in the Northeast, where there's a very low number of electrification currently? Low-hanging fruit. Well, I think that apartment complexes are easy, but I focus on them. You put in a heat pump boiler that's carbon dioxide, so it works, the refrigerant works really well in the wintertime. And then you get rid of all those really old, inefficient furnaces, radiators, and you put in a different system there. Yeah. Okay, moving on for a second here. You guys are interested in this, and I want to make sure you get it out of me. So if you're designing for off-grid or something like it, you're going to think about the winter energy efficiency because that's the pinch point. You have the least amount of sunshine, the coldest days, the water comes in the coldest. Everything about the wintertime is harder. So you design for winter. On the left-hand side, this is the heat pump water heaters that we chose. We're putting these water heaters in the apartments, in a closet. So that means they're pulling air from the inside, and they're providing free air conditioning because this passive house building needs air conditioning essentially 10 months of the year. So this provides a little tiny bit. How much, you say? Well, a heat pump water heater runs for 1 to 4 hours a day, and it's putting out the same amount of chill that you would have coming out of a refrigerator freezer if you open up both the doors. Not that much. It's a 4,000 BTU compressor. So we're going to chill the apartment a little bit, but that means that we have access to warm interior air and providing free air conditioning, which this apartment needs most of the time. The other choice we could have done is what I was recommending, which is a Sanco 2 or similar CO2-based refrigerant heat pump. Like we would have put it outside on the roof or something, run hot water around in the building. So the coefficients of performance, which translates to efficiency, COP of 3.1 versus 3.5. So the larger the number, the more efficient, smaller is worse. So this Reen tank, which is a 120 volt, and you can plug into any outlet, it has no electric resistance backup, very deliberate to avoid, electric resistance backup is very wasteful. It operates like a third of the time unnecessarily. So chose a heat pump that doesn't have electric resistance as its backup, so we could save energy. Totally real. In the wintertime, we lost some efficiency because if we'd used an outside CO2 heat pump, we would have had about a COP of 3.5. So maybe we lost 10% by choosing a less efficient type and sticking it inside the residence. But look at the price. $3,800 an apartment versus $14,700. Those are bidded prices for using the central system versus in apartment tanks. I love putting tanks in apartments. These standardized, factory finished, no field installation systems are the way to go in terms of cost effectiveness. Same thing. This packaged heat pump, which was deployed first like in the United States in Vancouver, that's where I learned about it, but it's pretty hot, hip and popular in New York City. Take out your radiator, stick this right where the radiator goes and put a little hole through the wall. And now you've got a controllable heat pump for every apartment that's super efficient, as opposed to like the least efficient system you can imagine, which is burning gas downstairs and heating an entire building's worth of recirculating water to then go to radiators, which are inefficiently built from 50, 80 years ago. Like, there's nothing about an existing New York City apartment building that is a good idea. So this is a terrific solution. The Efoca, so I should say Efoca because it's Italian. It's also 120 volt, plug it into any outlet, perfect for retrofits or new construction. I'll show you that in a minute. And the alternative to it would have been a multi-head ductless mini split. Would have put a compressor outside, one refrigerant to each of the rooms, put a fan coil on the wall. This is a fan coil heat pump refrigerant thing, but it's just not field installed. Carpenters install these, which is why if you have, say, 3 to 4 of them per apartment, because you put one in each room, bedroom, and then one in the living room, right? $11,000 per apartment versus $15,000. HVAC is the most expensive system. It's 3 to 4 times as expensive usually compared to domestic hot water. So you're paying like 15 grand for an HVAC system, $1,000 for your stove, 1,000 or less for your dryer, 4,000-ish for your water heater. It means focus on the HVAC system. It is 3/4 of the cost of the systems that you're going to put in that use energy into an apartment. Pardon me, I'm getting over a cold. So we went with these AFOCAs and the COPs, coefficient of performance. The AFOCA is a 3.5. The most efficient ductless mini split on the market is a COP of 3.2 in the wintertime. These are more efficient than the best Mitsubishi ductless mini split you can buy. So we won on this one, both on money and on efficiency in the wintertime. Induction ranges. So the cheapest induction range is $900. A so-so electric resistance stove is $700. These are very small differences when you're looking at an $80 million apartment complex, which each apartment is $400,000 to $800,000, depending upon where you're building in California. Like, just get a better stove, Get $150 worth of pots and pans also, because many people don't have induction-friendly pots and pans. But the reason why you do it in apartments is because electric stoves, electric resistance and gas stoves will both burn down the house. Both of them will melt an aluminum pan. Both of them can, if you leave a pan on, like senior housing frequently happens, people forget their pot or their pan and they light the apartment on fire, or they fill the entire apartment with Teflon smoke, which is caustically, dangerously poisonous to your lungs. It's full of dioxins. So one of these cool passive house projects that is going up right now in Washington, D.C. on the Beltway that I've been working on for years, the cousin of the developer is an asset manager. So he's in apartment complexes doing the work. He's literally the first responder when there's a fire. He has twice run into a senior citizen's apartment who have let their Teflon pan catch on fire, and he was the person who ran into the smoke, and his lungs are effed up for the rest of his life now. He got lung damage from 2 first responder experiences trying to rescue someone's Teflon pan from burning. Induction stoves don't burn Teflon. They stop at 450 to 475. They just don't get hotter. And you don't need that hot to fry food. You're like, frying food is 350. So just for safety alone, you should get induction stoves. It is a very smart investment in your whole house, a few $100s more, and you don't have a very low risk of fire now. And then these are the first commercial heat pump dryers, and they cut energy consumption by about half compared to electric resistance, and definitely 2/3 to 3/4 compared to gas. They save so much energy that we saw like a 7-year payback on them. So these are coin operated, or they're card operated. There's no coins involved anymore. But like a little app kind of thing. And these are the laundromat washer dryer, or laundromat dryers. Any questions on that? I'm just gonna look in the chat here. There are so many comments. I am having a hard time. You can do a tiny drainage plan. These numbers for the Rheem heat pump, is that base or south or northeast? The heat pump water heaters themselves cost $1,600 to $2,400 to purchase, depending upon 40 gallons to 80 gallons and the manufacturer. So that's what they cost. How much they cost to install is totally markup based and labor based. But these are being installed in the North Bay of San Francisco, one of the most expensive places in the nation to build, period. The Bay Area is arguably the most expensive, even more so than New York City, or more so than Miami. So $3,800 an installation is a great price for production construction. If you're retrofitting, it's more like $6,000 to have someone come in and install in the Bay Area, where it should be $4,000 almost anywhere else in the country. So that's pricing. Sarah, you're pointing out that, okay, Ahajo is saying using cork siding with a rain screen, I guess, defeats the purpose of insulation. And then someone else says, well, it has fantastic insulation properties, R4, nice and quick drying, great thermal bridging reductions, thermal resistance doesn't decrease over time, sound dampening. We like our interior facade in the office for this. Yeah, you can put insulation on the inside or the outside. It still does the work. You can put cork and then have a rain screen. It still has done the work with that 1/4 inch, 1/8 inch work of reducing heat loss. Little air gaps are fine, for insulation. Okay, then we did it. We're at 9. Oh, shoot. Okay, so we're putting in a bidirectional parking lot. It's one of the ways we're closing that last 5%. People's cars. So this is already being done over in Utrecht. They have more than 500 cars distributed. They're putting out 100 more this year. These cars have bidirectional chargers. The car charges the grid. And that's how we're setting up our parking lot, is that if we need grid electricity a little bit in the wintertime for about 3 weeks of terrible weather over the course of the whole winter, from like November to March, the cars chip in. Terrific financial case for it. They make money this way. The law in California is that all electric cars have to be bidirectional by 2028. Here's all these headlines of cars announcing that they're going to comply. So 2028 models or sooner, all Teslas now are built with the bidirectional charging that they need, although their software hasn't released it. So there you go. This is huge batteries. A home battery that you put on your wall is like 5 kilowatt hours to 20 kilowatt hours. You buy a car, today it's a 60 to 130 kilowatt hour battery on wheels. Massive amount of capacity. There's more than 3 times as much car batteries driving around in California than the utilities have installed combined. Like, it is the world's battery resources, cars. Globally, that's what sells batteries 3 to 4-fold more than anything else is just car batteries. They're a fantastic resource. So that's the end of that quick little story. Cool apartment complex, solar powered, super insulated, low cost winter energy efficiency, cars filling in the gaps for the solar array. Then I'm going to briefly say here's swimming pool heat pumps. Little sizing metric there, 4 BTUs per hour to 6 BTUs per hour per gallon of pool water. We'll cut your operating costs by half to 4/5. They are so efficient. I was showing you COPs of 3.14, that kind of thing. These have COPs of 9 to 13. because they only raise water temperatures, say, from 70 degrees to 85 degrees for a heated pool. So the efficiency gains are massive. Here's your fireplaces. If you want to have a fireplace that is not having combustion, you get a mist-based fireplace. Tons of them. You can get them for $20 online at Amazon now. That are just like little mist fireplaces for your table, but you also can get whole ones for the wall. They come with electric resistance heaters, so you get blasted with warmth while you're looking at a completely authentic looking flame. Ashley, you're saying, how fast do the models heat up the pools? So many variables involved in that, but that's a separate conversation. Let's hook up, and because I just can't do it right now. But here you go. Mist fireplaces, stoves. Of course, there's everything that just looks like a stainless steel gray or black. But did you know that they also come in every antique variety that you could want? And they're from $3,500. The Smeg, fancy. 5 burners, 4 ovens, etc. $2,200 AGA. Quick story, the inventor of AGA was a chemist. He blew up his face, was blinded, and decided that he was going to make an electric stove for his wife so she would never have to cook on gas again. And that is the origin story of AGA, which makes terrific induction stoves to this day. Lovely, this is what it looks like for normal people. Just point out that babies can be next to induction stoves, whereas the amount of smoke that's coming off of 2 gas burners, you turn 2 gas burners on high, that's the same amount of gas smoke that's being produced by your car engine while it's idling in your garage. Would you put a muffler into your kitchen? That's how much smoke it is. Differently put, people who cook on stoves have the same health consequences as people who live in the house with a secondhand cigarette smoker who smokes in the house a pack a day. It's the benzene, it's the nitrous oxides. It is intensely polluting, and it's just sad that it's invisible and odorless because it is filthy. And you should not let kids be in homes that have gas stoves in the same way you wouldn't send your kid over to a babysitter who's smoking in the house all day. Like, that worked for me, quote unquote, when I was a kid. That was Marge. She smoked in the babysitter's place and she would hit us with a stick. That's like 1981 babysitting. But it's 2025, right? You don't put kids in homes where people are smoking cigarettes anymore, which is what a gas stove is. It's just a cigarette stove. If I'm using this 15 minutes here, so I mentioned before how all houses have 100 amps now delivered to them. This is an example of a home that we got a big prize for. We did 2 houses on 100 amps. And this is just all the technologies. They're all very efficient. They generally don't use electric resistance, not for space heating or water heating or for drying the laundry. It's all heat pumps, which collect the heat energy, 3 to 4 times as much usually as you use to collect it. Batteries and smart panels are coming in. So if you do have a 60 amp panel in an apartment complex, you can use smart panels like EcoFlow or SPAN. And these will balance just in case if you ever got up to 60 amps, and it's almost impossible to use 60 amps no matter what you're doing in a house. But if you did, it would shut something off that you had deemed non-necessary to let other things operate. I'm going to go fast because these are all the extra costs. Everything in blue is an extra cost if you put in gas. All the yellows are where the leaks are, because keep in mind that using natural gas, burning it is not as bad as the leaking of it. We have somewhere between a 2 and 10% leakage rate. It's really hard to pin down, but we know there's at least 2%. 2% that's leaked is equal to the 98% that's burned, because methane, when leaked, is the world's worst climate change chemical. Right now, 40% of the climate change we're all experiencing is from leaked, not burned, methane. It is the worst. And so the goal is to get all electric homes, not just a half electric, but get all electric, because one of the big leaks is just the meter. They have a pressure release valve at your meter that leaks gas to make sure that it isn't overpressurized. And by the way, Ashley, you asked, does Savant do load shedding? I don't know. Not many of them do load shedding. This is heat pump water. Here's for like the high rises. These are ones outside us. And this is energy savings and cost savings. I'll just say you save both energy and money when you convert to heat pumps. These are developers saying, hey, I saved money. I got 4 of them to get on the record and say how much money they saved. And this is why their entire company is converted to all electric. That's it. trying to get us done on the 10 minutes. Yeah. Okay, there you go.
Excellent. Thank you, Sean.
Yeah.
That was awesome. I feel like I got a whole year's worth of fun facts around electrification, and people at any gathering or party I'm at better watch out.
So I'm not sure if people could see that, but because I had this screen being shared, this is a response to one of the questions that people had, like, can you give me some ammunition? This is the 1994 study. This is great because this is at a time when people were still smoking in their homes. So you could get 300 women who had a guy smoking in the living room, and you can get another 300 women who didn't have a guy smoking in the living room, but were cooking on gas. And they could show the comparison of the amount of heart attack medication, asthma, wheeze, all these symptoms from living with someone with cigarettes are the same symptoms that you get when you're the person cooking over a gas stove. So this is one of my favorites because it actually had cigarette smokers in the study to pull that issue home for you. Yeah, thank you, Kim, for sticking that in there. Mary James, you'd love to get the brand names for the heat pumps for swimming pools. Okay, so let me show you. I have all these publications that people can use. These are guides to how to retrofit things, right? Commercial buildings, single family residences, the rest of it. And then down the list is one on swimming pools. Advice, where is this? All sorts of things. Technical. Heat pump, pool heat pump strategies. And I'll put this link into the chat for the person who wants swimming pools. Paste, boom. And so this is a guide for sizing, a guide for products. It's a Bay Area specific one, so it also has like phone numbers to call of people who do heat pumps for swimming pools in the Bay Area. And I'm going to try to zoom in on this so that you can see. Talkity talk. The addresses, the folks. And these are businesses that Aquacal, Hayward, Raypack, Pentair. These are like big names. Aquacal being the world's largest swimming pool heat pump manufacturer. And then they got like the gas ones. These companies also make gas versions, Hayward, Raypack, Pentair, Aquacal, which Aquacal does not manufacture gas. They're just heat pumps only. And then some sizing details. So if you're looking for brands, these are the ones I would suggest you start with. And Aquacal, for instance, also has models for hot tubs. So that's how you do it. Get one of those brands, and it's not that hard. Like when you go to Hawaii, you're usually swimming next to a heated swimming pool with a heat pump there. It's very rare that you'll see a gas, particularly in Hawaii. Okay. Any other questions? I said I'd stick around for a few minutes for that.
Well,
Yeah, I think you've done a great job on this.
Great.
Oh, sorry.
That's okay.
Go ahead. Now, I was going to say that I was trying to find some of the questions that there may be on the chat, but I think you've been explaining them and just addressing them as they go. I think there's one from Tom Phillips that I don't think it's been addressed about PV panels. So if Tom Phillips is still on, I think he can go on and read that one.
I saw that.
Or his question, yeah.
You wanted to know, like, is Tom there? You want to know, like,
I can read it for you if you want. The orientation of PV panels, some recommended southwest type orientation to reduce peak demand on grid. Looks like the Petaluma project uses south orientation. Does it make sense? In some cases to optimize peak PV power for some or all panels?
No, not much. I mean, even in our off-grid situation, we'd strongly consider, like, what if we're trying to design for winter, we should probably put the panels up higher so they get an orientation when they hit it. But that only meant that we shaded all the panels behind us, and we reduced the amount of square footage that we could put panels in. So we found out, no, actually a very gentle angle, which allows us to squish more panels physically onto the site. Now that solar is so cheap, this is the most cost-effective way to do it. Yes, 20 years ago when I was being trained and panels were more than 10 times as expensive, we would definitely orient things, angle them, all the rest of it to try to squeeze the most out and reduce the amount of panels that we had to put up. But the economics have flipped. We're now put as many panels on as you physically can, including on the north side. Like north side gets sunshine in the summertime, which is when the sun is strong. So if you lose 20% by putting panels on the north side of a roof, or even 30%, hey, you got a lot of extra roof and panels are cheap. So all dimensions of roofs these days get solar panels if that's the goal. But certainly, south, east, west is better. But the economics are is you put them on the north side too. You
Yeah.
try to squeeze as much as you can.
Yeah. And if anyone's on the South Hemisphere, I guess it's all flipped in
Yes,
terms of what you just discussed.
my bad. Yes, right.
Um, I think there's no new questions unless I've missed them. Just one comment from Mike. Can someone list recommended ground source heat pumps? But I guess it's more of a question for the group, if they have any recommendations for that, or if Sean, you have any ground source heat pump recommendations. I guess it's worth noting it.
Okay, so let's go to the retrofit guide for a second here. So the guide is set up so that you can go to your right heat pumps, all electric products, cooking. I'll zoom in so it's not so blindingly tiny. Okay. Heat pumps, swimming pools, hot tubs, heating, ventilation, air conditioning. Okay. Geothermal is what you're talking about. So we're going to go through the ducted types, discussion of crankcase heaters, which are terrible, 120-volt fan coils, which is great if you're replacing a system that's gas and you just want to use electricity nearby. Pricing, cool interview with someone who's like the leader in the industry on heat pumps. So if you want to learn about how things get priced and why, there's a great chunk on that. I'm just going through all these air source heat pumps, which is my preference, packaged ones, little do-it-yourself systems so you can plug it into your window. These are to air to water for hydronic floors, hot tubs, things like that. And geothermal, here we go. Water furnace is kind of the world's biggest brand, but Nordic, Water Furnace, York, Geostar, and Bosch are industry leaders. And there's others, of course. This is not a difficult technology to design because you're pulling up warm liquid from the ground. Air source heat pumps are dealing with like cold air in the wintertime. So ground source heat pumps are pretty popular in upstate New York, Canada, places like that where air source heat pumps are more challenging. That said, the economics are still about central Canada before you would want to go to a ground source heat pump instead of an air source heat pump because the air source heat pumps are just so cheap to install. And all they really are is a fan. These things have a pump that circulates water or propylene glycol, et cetera, down underneath the ground very deep. It's expensive to install to get the access to the warmth that's in the ground versus a bigger fan, a better refrigerant for an air source heat pump. So I don't advocate for them because I don't live in northern Canada. But and back in the day, it was a good idea. But now that air source heat pumps have computers, that's the way to go for cost effectiveness, in my opinion.
Right.
Okay,
Yeah,
I guess.
there's a world out there in terms of equipments, and you need to learn all of them, right? So it's incredible. You have so much knowledge on all of this. Yeah, I
I'm
commend you for it for sure, and thank you for the guides.
absolutely. Ask me anything. Like I've been doing this my entire life. I was 19 years old and I was like, I'm suicidal. I'm gonna just focus on solving things. Only that. And so my whole life I've been trying to learn the technical knowledge to solve these problems. And it's absolutely my passion and interest. And you're not gonna find anyone who has done it longer or knows more.
Yeah, applause to you. And I think we'll do an AMA. I think Zach could confirm or deny that, but I think there will be time to ask you more specific questions.
Yeah,
In
next Friday.
Imagine buildings. Yeah,
Yep.
there we go.
We're gonna have a good time.
So I think we'll wrap it up for now. Thank you for taking the time and the extra time to sit down with us. And I would commend everyone to join us next week for our Project of the Month event, mission-driven passive house featuring the Mercy Green Bray, the Mercy Green Bray at Merrillhurst Commons in Lake Oswego, Oregon. I hope I said all that correctly. So until then, we'll see you on 2025 for more Passive House Accelerator events.